Hey everyone, I'm Suyog from Team Mavericks. Team Mavericks is team of two participants, me and Viswak. So I'm going to talk about how our program works. So this program controls uh, our autonomous rover designed to travel through a sequence of waypoints and adjust its speed, making steering decisions, avoiding obstacles, and maintaining a proper camera exposure. So first, a little overview about the control system. So it will constantly receive updates about our position, velocity, orientation, and camera feed from its front camera. And using this information, it computes where it should go next and how to get there safely. For steering controller, so we have used a YOLO model. So a YOLO model will detect the obstacle, that is rock, in the Martian surface, and whenever it sees a rock, detects it, it tries to steer away from it to avoid the collision. We also have a inbuilt algorithm with, if the rock is too close, it will steer with more intensity, and if it's a bit far away, it will steer with less intensity. um, and we also have speed controllers. So the speed of the rover depends on multiple factors, such as if there are obstacles in the zone, it will slow down uh, the speed. When there is rocks around, it's 16, and when there is not, it turns up to 30. um, it also depends. We also added a special filter. When the rover is close enough to its waypoint, it slows down. um, we also have our exposure controller for the camera, because there are days, nights, and storm in the Martian environment. So whenever the brightness of the camera feed is low, it will change the exposure as needed to get the best out of the given feed, which has worked pretty well for us. And moving on, it's a YOLO based rock detection model. So whenever it sees a rock at left, it will try to steer away right, and whenever it sees rock at right, it goes to the left to avoid it. It will also gradually increase its acceleration to avoid the collision, and slows down when it does not see the rock. Also, if it gets stuck in a place, it will reverse for a few seconds, turn left while reversing, and slightly move forward left, and it will reset the stuck flag. So yeah, that's it, and my friend Vishwak will explain how the YOLO model works.
We trained a YOLO weight model to detect rocks of varying sizes in the simulated Martian environment. We collected training data by recording the ROS bags while manually driving the rover around through the Mars simulator, capturing images of small rocks, large rocks, and no rock scenarios. Our initial model, trained without image augmentation, faced several challenges. It struggled with partially occluded large rocks, misclassified shadow regions as separate objects, and showed reduced performance when the environment had a white tint, representing the reflective conditions of day 2 and day 3 scenarios. To address these issues, we implemented a comprehensive image augmentation technique focused on hue and saturation, along with augmentations to handle occlusion and varying lighting conditions. This augmentation strategy significantly improved the model's robustness, enabling accurate detection of partially visible rocks and proper handling of shadows across different environmental conditions in the simulated Martian terrain.